Hello and welcome to Gus Codes. I am Gus, and in this session of xganso I will implement the tactical movement mechanic of xganso using ECS. Despite sounding simple as moving units from point A to point B, this implementation requires careful design. Currently, xganso has a renderer system that's overloaded. Based on the grid position, the renderer system calculates implicitly the world position and screen position to draw the sprite on the screen. To enable the new movement mechanic, I'll make all positions as explicit components, world position and screen position. The screen position will be used by the rendering system to draw the sprite on the screen, and it will be calculated based on the world position. The world position on its turn may be updated directly or synchronized with the grid position when the grid position is changed. Once the renderer is refactored, we can move on to the movement mechanic, divided in two parts, planning and execution. The planning part depends on the destination target, which is represented by target grid position. The path calculator system will consume the target grid position and calculate the path from the entity grid position. The resulting path is stored in preview path, which is used by the path previewer to draw the intended movement. The execution part is triggered with a move command component to the start movement system. The system converts the preview path to a path. Then, the path stepper system iterates over the path next cell and creates a movement progress component that represents the movement between the current and the next cell. Lastly, the movement system executes the movement described by the movement progress using speed and delta time. As we can see, implementing a mechanic in ECS requires careful design to understand the system workflow and the lifetime of the components. I feel we manage a good design for our new mechanic and we are ready to implement it. Let's start coding. Let's start with the renderer refactor, but first let's make one small improvement in our ECS framework. With this change we can get the entities and the components directly. Everything is working. Now let's split the renderer system and the components. We're calculating the coordinates and we are adding a component. So if it already exists, it doesn't matter, just overwrite. So we don't need to query if it already exists or not. The world to screen position is done every frame. So we also split this sprite scalar system because it was also doing two things. Now we have to set up all these new systems and test it. And important is that they have to run in a certain order, I guess, or maybe it won't be a problem. And as a start, we need to add a grid position changed component. I think I'm also gonna convert this x coordinate for that one, and for these two I'm gonna use a vec f2. So we just have to adapt now everything. Position is ready, so it will simplify a lot, I think. And then this is a vec f2, and we can just pass it straight away. And here we have to put point, and here also we can put straight away, and here we have to say point stop. Okay, let's try and see if this works. Something with returning a tuple here, and it's slightly annoying. Okay, maybe we'll make another method with component, and we put single components just to be easier to understand. And then here we say component type, and then get entities with, maybe we can just pass it like this, we'll see. Nice, nice. So now everything seems to be working as it was. Everything is displayed, everything seems to be in order. So our new render system is working, and now we can do our movement system and update our word position and make the movement. Okay, I think these are all the components that we need. Now let's make the systems. The first system will be the path calculator, and here we need to use our pathfinding. So right now I'm just gonna assume, I'm gonna implement all the correct checks. So first of all, I need to check actually all the components that have a target grid position, and then here, because it may be the case that it doesn't have a grid position for some reason. Okay, so first, if there is a grid position, we'll calculate the path. It could be that the path is empty or impossible, so in this case, we won't do anything. If there's a valid path, we'll add this component as a preview path, and in any case, we remove this target grid position because we don't want to calculate every frame, just want to calculate once, and then it should be fine. And then whenever there's a new target grid position, then it can calculate again. I think this is the one that's valid, so we update the path, and well, let's see who uses this path now. Okay, so we have our first problem here, is that we receive the preview path as a list of cells, and then we have to convert this to a point in the world. It's a little bit unfortunate. So this was a little bit unplanned. Let's see how it's gonna be. I think that at the moment, because this is more a preview, in the future I might use the cell per se, but now I'm just gonna use a single line, I think. So I think at the time being it's okay to do some kind of overload there. Okay, so we have the two systems that we need for the preview. Now we have to mock our input. So here we have the events. Okay, let's give it a shot. Press P. Ah, yes, of course. It's not a hex coordinate. It's a target read. Okay, let's do some debug here. I'm gonna see if something is executing there first. It should be planning the movement. Has a target grid position. Maybe it's not a valid position. Let's select one. What's this one? -2, -1. Of course. As always, I have to add those systems to be executed. Okay, now what we need here is screen layout camera. Should be easy. And here for the path calculator, we need the hex map. I always forget to use the data inside the components. Nice. So we have everyone moving a little bit. It seems to be working. Great, great, great effort. So this was the first part, the preview, and now we can do the actual movement. So the actual movement is gonna be similar to here, but when I press move, then I'm gonna do for all entities, let's go move entity here as well. We're gonna do a move command, and that's it. So that's the trigger. Okay, let's start with those classes. Yeah, this is gonna be a very simple one. The idea is only that we are gonna take the current preview path and convert into a path. And we are also removing the preview path. Maybe in the future it can be something that's consumed as it goes a little bit more complex, but for the time being we're just gonna remove it. And of course we have to here is a move command, and we have to remove the move command as well because we only want to trigger once. So the next one is the path stepper system. Let's see what we need for this one. We need a path course, and that's it, I guess. We start with next cell. So I think we're gonna use the grid position here as well to determine which is gonna be the current position. So the paths hex cell and the grid position is hex coordinate, which is fine, I guess. For the time being, everyone is gonna have the same speed because it's mostly for the animation. To be honest, I could put that on the other one though. Yeah. I need here if I put the layout here, it's easier, because then we just have to calculate once. So of course if there's already one movement, we just should ignore. If we are already on the target, then we also should remove the path, not do anything, and I think that's it. Now the final one, that's the interesting one. That's where the movement is gonna happen. Let's see what we need exactly. Here is the part where there is a delta time, and I think now is the part that everything should have the delta time. Still have to see a clever solution for that, but this one needs the delta time. It's the first one that needs, the rest doesn't need, so we just put a underscore, but we'll see how we're gonna handle with that in the future. So if we reached our destination, we remove the movement progress and we say the grid position change, so we will snap to grid position and update it, and now we are gonna trigger again the path stepper system because it doesn't have a movement progress anymore, and I think we can just return here. Well, I'm not sure about the math too much, but let's see how it goes. We have to add all the systems. How do I get the delta time? The same thing, we process if we have, otherwise we just remove. X coordinate is no object, because it is a coordinate already. Maybe we can do different. Maybe we don't need this progress. We can just say forward position point minus movement progress destination smaller or equal than, and then we'll need this. Okay, close enough. Close enough. I think I need to do some research on how to update. In Unity they have something. They have this move towards. Okay, let's try something similar as that. Let's try this approach from ChatGPT. So first we need the origin and the destination. And then we need the direction vector. Okay, if we are already there or if we overshoot, then we go to the destination. Else, we normalize. Our word point is now our current position plus our normal vector times this step. I'm pretty confident now. I think it was roughly the idea that I was trying to do. Whoa! Okay, it's too fast. My speed, maybe we have to reduce it a little bit. So let's reduce a lot because we want to see some animation. Yeah, still a lot. Must be real number, not double. Okay, let's move everyone at the same time. Not working. Okay, let's just set one, that's fine. And let's see, why is it not working? To have multiple movements. What is happening here? So the second movement is not working. Why is it? I don't really understand this part, to be honest. Okay, so I think this fixes this part, but now the question is, why is it not executing? Let's see what happens in this one. Okay, the movement is a little bit wrong at the moment. Maybe it's the path previewer. Yeah, it's out of range. So we're doing the reverse. This is okay, I guess. Now here's the problem. Next cell should be like this. Because I was asking if it has a component, and of course it has, because it added, so only the first movement would be possible. Okay, the movement is horrible, but it's reaching the destination. Perfect. I mean, not perfect, but at least it is moving. And let's see, maybe here the direction should be, instead of word position, should be the origin. It went forever. No, but I think here should be the movement origin, but then the distance doesn't agree. Here it should be length, and here I say distance equals. Let's give it a shot. That's weird. It's not going to the right place. Okay, so let's see what we have here. Because the word position says I'm in this point. So what's that origin? Ah, I know what's the problem. I'm doing hex top left here because I have to print there. It is a little bit better, but still not quite. Okay, seems to be working, but they are moving in steps that it's not very nice. I wish they would all move at the same rate. Okay, I think with that, I think it's good enough. For the time being, we had a lot of issues with some data, so let's just call it. And I'm happy with the result as the basic implementation. Of course, we can still improve a little bit. And yeah, that's it for today. So I realized what's the problem with my current implementation. So the problem is that I'm returning here, and I should just put this continue, because if the first one meets this condition, it stops the entire loop for the other ones. So with this continue, it should fix the issue. Yes, exactly. Now it looks good. Now I'm happy. To summarize, today we implement the tactical movement mechanic of xganso using ECS. Despite our careful design preparation, the implementation had some issues with data types and the miss returns instead of continue. Overall, I still think it was a success, especially because of the nice structure that we achieved. Let's review the code changes. In the main battle, we added all the components and the systems, and also we added the delta time, and we added this mock input handling. We deleted the grid position and moved to the position. In the position we have all the 3 position components and the grid position change. I'm gonna remove this top left. I was thinking about it, and we can remove that. We can remove in the movement system, we don't need it. So I realized that we can just take the center point and move according to the size of the sprite, and we'll get the same result. Okay, so now it's a little bit simplified. The path are all the components for the path part, for the calculation and the movement. Currently we don't have the progress, and the movement progress is a little bit weird. We have to improve that in the future, but for the time being it's okay. The sprite now has a screen sprite. That's the component that is adjusted by the scale. The movement is a new file. It has all the path calculator, path previewer, start movement, path stepper, and movement system. So all the 5 systems that we plan to do according to the planning phase or the execution phase. We moved the renderer system away from this file and moved to renderer, and we created a new system. So we have the sync grid to word position, word to screen position, sprite scaler, and then finally the renderer. And we extended a little bit now. our ECS framework, we added the delta time, and also we added these two nice methods that get the entities with the component. So we had to do a single component and multiple components, and they execute with the delta time. So we have all our changes, we commit, and then we push, and we're done with this one. In the next session, we will continue to implement game mechanics with the combat mechanic. We will focus on the overall systems and components, leaving the actual calculation and formulas for a future session of game design. Thank you for your time, and see you in the next session.